Good morning, good afternoon, and good evening, everyone. I want to welcome you at the next session of the Global AI Community on Virtual Tour. And we already have our next speaker online, Akanksha. Hi, Akanksha, how are you?
How's it going?
Everything is cool here. How are you? Where are you
We are,
talking from?
we're in Melbourne, and surprisingly, and maybe not from Australians, but it is cold. It is very, very cold here.
Is it?
Australia is
Nice.
all a big lie. It actually just gets really cold all the time. That's what it is.
Uh, okay, and what is the time there?
It's bright and early at 9 a.m. There's been many coffees
Wow.
had this morning so that I can actually talk at 9 a.m. 9 a.m. means I'm starting up, so we'll hope for the best.
Okay, so I'm just going to introduce you. So Akanksha works at Tesla Purple as a data scientist, and she works with clients to help them solve problems by making more informed decisions by data. So she loves machine learning and that it is becoming more accessible to everyone. And she is currently the director of Women Who Code in Melbourne, which is pretty impressive. So what are you going to talk about today?
So I'll be talking about Azure Synapse Analytics. It's a brand new product that is still under preview in fairness. So it's just a quick look into what it can do and all the AI and BI capabilities that it has.
That sounds very interesting. I think the stage is yours now.
Cool. Thank you all for joining in. And just a really quick shout out for all the people who are actually organizing the event itself. Everyone on the committee, thank you so much for putting the time and it takes to join us all together in these isolation times and the pandemic that we've gone through. But yeah, let's dive straight in. And I like to go really, really in depth at the first and talk about myself because it's always the easiest place to start. It gets me into talking a little bit slower as well. So a little bit about me. I am from Ireland, as you can kind of tell from that photo of me looking really Irish. I grew up in Ireland and went to uni there and studied financial maths and actuarial science. And as Eve mentioned, I currently am in Melbourne. So I moved here about 2 years ago and started working at Tesla Purple, which is great. We got to find out all these things about machine learning and explore all these new things in data science. And last year in November, I actually got to go to Ignite. And at Ignite, I got to hear about all these products that were incoming, especially Synapse, which what they told me was this is one place you go into and you don't have to leave it for an end-to-end solution. And I was like, yes, this is what I want. Tell me more, because I don't have to use connection strings. I don't have to forget what connects where and like how data stores have been connected to my machine learning studio. This sounds amazing. And that's just a photo of me at Ignite and just a little tidbit. Sorry, this just usually gets a good laugh. But on the top, on the thing, it says Data Queen. And I'm not asking you to refer to me as one, but if you do refer to me as a Data Queen, I will accept that. Like I will respond back to it. Um, so yeah, this is my first time really presenting remote. So it's a little bit weird, a little bit awful because I can't really see anyone's reaction to this. So I'm going to pretend everyone laughed at that and we're going to move on from there. But now that we are talking about Synapse, what is today's agenda? My agenda essentially is because I've got an access to the preview, I want to be able to share it and showcase kind of what AI and BI capability this has and how it works, all of it integrated together. So taking a step back, if we just have a look at AI in the market, it's kind of everywhere. Everyone wants it. It's the newest buzzword going at the moment. All these new topics keep appearing that are being powered up by AI in the background. And enterprises really want this, which is great. But there's challenges with adoption to having AI, right? So there's people like finding the talent and the right talent to actually be able to implement the solutions you'd like to be deploying out there. Language barriers with actually coding up those solutions exist at the moment. Processes, setting up an environment can take a lot of time. I think I was on a project a couple of months ago. It took me about 2 weeks to actually just get onboarded and get everything set up on my local machine, which is a pain and it's a cost at the end of the day. Managing all those infrastructures is always going to just be a little headache that kind of sits there. And the technology itself, we're building out all these great solutions, which is amazing, but the security and the scale of the whole product and the fact that it needs to be flexible still exists. Okay, great. You've come up with this amazing solution. Your data science team is really well versed with Python and they've created the solution in Python. But what happens if that person who's created it has to leave or whatever might happen, they're not available to you. The only other person available has our skills. They can't really communicate with the two, and how do they change that solution for you, and how do you help out? That flexibility issue always kind of exists. And on the other end of data problems, you see enterprises getting into the market of AI, which is great, but they struggle to actually mature. Everyone will enter the market, but how do you really become a proficient and efficient user of the data that you have, and how do you make the most of it? That's a struggle that people report. And the other main one is the data silos that exist at the moment. There's two main ones, and they cause a bit of a pain, especially in enterprise level where there's a lot of data to handle with. So what are these data silos? So there's two big ones. There's the big data and then the relational data. They kind of sit in two different places where the technology that kind of talks to those databases and stuff are different. And they haven't really been able to connect all that well, which is where Synapse is created. So Synapse ethos essentially was, how do we make this little problem that customers are facing, how do we make it easier? And it's essentially to create a platform where you can talk to both silos at the same time. So big data and relational databases, everything in one place that you can query from both, create solutions that have data from both places, and just the whole integration of it is seamless. So looking at Synapse as a whole, that is a very busy slide. I won't lie, I don't like a lot of things on my slides, but this is what Synapse has. So we'll talk through a little bit in detail and just break it down a bit just to make sure we kind of understand what's happening and how it's all been built out and what the aim for it is. So our ingestion of data exists where they've given you the ability to actually import data from, I think, 85 plus sources, which is kind of stayed true to almost all data products that they've released. You are able to pull your data in from wherever you'd like, whether that be from on-premise or some other cloud provider, does not matter. You should be able to pull it in quite seamlessly and pretty easily. And that all then goes and sits inside of an Azure Data Lake storage, which is really well created and kind of chosen in terms of it handles big data well because it has hierarchical name structures and also handles like relational databases as per as you usually would. So that's great. You've pulled in your data from whatever source you might have. It's now stored in your data lake storage. What next? You're usually going to be looking to actually clean up that data, transform it somehow, or maybe even just put some AI behind it and actually train it up and create some models from it. And that's great. They've actually integrated Azure Machine Learning actual products within that studio into Synapse as well. But it also has Apache Spark. So if you didn't really care about the integration that exists with AML, that's cool. You can actually sit down and use a notebook, have your Spark ready to go, and create your own solutions from that within Synapse as you are. Once you have created your databases, your data is there, and all the smarts, it's all transformed, looking pretty as you'd like. We've got SQL runtimes to serve up your data as we have in the past in data warehouses. But the other big thing that you'll see in an end-to-end solution is, okay, great, you've done all this amazing stuff with data that you understand, but the business doesn't care. They just want the main insights that the data is providing. And those are usually kind of built up in some kind of reporting system, whatever that might be. What they Synapse has done has actually integrated PowerBI into the whole studio itself. So without having to leave that one desktop place of the studio, you can actually export that data into your Power BI, create the reports within the studio, and actually be able to deploy them from there. So that whole end-to-end process from ingesting your data all the way to actually delivering that data to your business all exists in one place. Talking about Azure Machine Learning a little bit, just so in case people might not have an idea, like Power BI is just a basic reporting system. There's a few different bits involved with Azure Machine Learning. It's just really quickly to get everyone on the same page here. There's three main products that Azure Machine Learning Studio offers. And this is in its original phase, like that you can actually go access at the moment. Notebooks and SDK. So these are kind of for your data scientists and your data experts. Like they know exactly what they want. They're going to be sitting there. They'll know exactly what libraries they want to have. They can go in, start coding. They'll know what models they have, what featureizations needed. They're good to go. And that capability exists in Azure Machine Learning Studio and has been pulled into Synapse as well. The other really cool feature, I think, is still in preview at the moment, but it's kind of amazing. So in Azure Machine Learning Studio, they've got AutoML. And this is for kind of really catering to that background of someone having no coding background and no machine learning experience behind either. But they know what their data is, and they know that the data could do something smart. Like it can predict, or it can be classified into things and just take the time out of their day to having to manually do that, which is great. Because in Azure Machine Learning Studio, when you use AutoML, it's about a 3-click process of here's my data, this is the kind of prediction I want back, go. Like, that's all you have to click in terms of clicking, dragging. There's no coding involved. And this is kind of where that accessibility point of view of, I love the word democratizing AI. This is really kind of standing true to that, in the fact that it's accessible to every single person out there. They've also integrated AutoML into Synapse itself. And what they've pulled into the fact is, that's great. Maybe you do have a bit of coding background, but you still don't really want to sit there and try out 30 different models and parameters and see which one works best, and having to iterate through all these different versions of them. AutoML can still do that. So if you're a data engineer, but you don't really care about the data science part of it, you know how to clean up your data and you know how to featureize it, off you go. That's great. You cleaned up your data and you can just throw it out AutoML in Synapse and it will give you a result back from that. Designer is also a product that Azure Machine Learning Studio offers, which is a drag and drop machine learning pipeline creation. They haven't pulled that into Synapse. I'm hoping they do at some stage, but it's not really a need or necessity in Synapse at the moment. So what we'll be focusing on are notebooks and AutoML and how they connect up with Synapse today. But what is my data? How are we going to be looking at all of this? So as a very basic example in a data science kind of scenario, we'll be looking at the New York taxi data set. It's a pretty handy data set because it is so vast and so deep. I think it's got like millions and millions of rows. We'll be looking at about a month, which is 10 million rows-ish. I went to America for Microsoft Ignite in November, and I've never been there before. And tipping was a whole new world. I was just flabbergasted at the fact that I sit down and do maths at every corner. I was like, oh my God, how much am I meant to tip? What am I meant to tip? So what the aim today is, I want to be able to know how much should I be tipping a cab driver in New York, when and if I can go to New York, and this whole thing blows over in a couple of months maybe. So with that, let's dive straight into our demo. And I'm going to pop straight into our homepage. So how do you even set up Synapse? Where do you go? Once it is available in general availability or even a public preview, you'll be able to access this. But at the moment, it's still in the private preview. So have a quick little peek at what this looks like. To create a Synapse workspace, it's kind of straightforward, and it has the basic requirements of just, well, I can talk through it once it actually loads. Yep, there we go. So you'll need your subscription, as always, and a resource group where this is all going to sit under as a solution. And the other thing that this actually requires is a Gen 2 data lake storage. This is the one time that you actually have to create something. Oh, I take it back. They've actually updated it. So you can actually create a brand new storage account from here in Gen 2 and a file system name underneath that as well. And that's all you kind of really need to be able to create a workspace. And once that's created, it looks something like this. And what you'll see here is just a bunch of details in the usual kind of UI that Azure has. And the main one that we're looking for is to launch the Synapse Studio. And it takes us sweet little time for about 10 seconds, and it shall load through. So yeah, this will be that one kind of workspace that we talked about, which will have access to all the different parts of your pipeline for a data solution, from ingesting all the way out to reporting. And if my Wi-Fi could please just perk up a little bit. There we go. So yeah, loads of different parts. So if you think about a data solution, the two big aspects of a data solution is obviously the data itself and how you get the data. But the other part is, how do you compute it? Like, what is the machine power you're going to be using behind it? So let's set that up to start off with. And what you can create are SQL pools. That's to handle any kind of SQL queries or anything related to SQL for runtime. And you can also create Spark pools. They're both pretty straightforward. So for Spark, you can have small, medium, or large size machine, and you can choose how many nodes you'd like to have in it. And then you can segregate those out into executors when you actually start to go and compute anything. So all Apache Spark Pool is just a basis that you can use to go compute things from. Similarly with SQL pools, you kind of just hit new, and all you're actually required to give it is what kind of a performance level you'd like and a name. So they've kept things really, really light and not too kind of busy on this whole studio aspect of it. That's great. We've got our compute set up. The other part of it is always going to be your data. And how do you get your data in? So there's a bunch of different ways you can do it. So there's add your new data set and off you go. These are all the different kind of platforms that they have that you can actually import data in from. Whatever you like, it exists. If it's in Google, if it's in Azure or Amazon, it's not an issue. They're pretty agnostic about what kind of cloud provider you're coming from. So you can pull your data in, you can actually connect up any kind of SSMS SQL servers and stuff. It is a data warehouse at the end of the day as well. So all of that capability still exists. It's just been enhanced. Once you've got your data in, which I currently don't, I'll show you how I did it through just pulling in from Blob Store. There's a bunch of different ways you can actually start developing. So we went through the kind of pipeline. So you've got your ingest your data, you've stored it in a place, which will be your Gen 2 data lake storage that's been connected up. And now I'd like to be able to do some transformations or some kind of training and testing on this. And there's a bunch of different ways you can do it. You can use SQL scripts. If you're comfortable with SQL, they've already built in kind of IntelliSense into this. So if I would like to say select, if I could do that without, yep, there we go. Select star from blah, blah, blah. It's all built in. It's very nice to actually start using this as well. I'll do example on a data set a little bit later. So we've got data flows. If you've used Azure Data Factory before, this has also been pulled in. It's just a really quick sample data here that I've got just pulled in of an Airbnb. If you pull the data in, cool, you can do all your transformations here. So if you wanted to select certain columns, and then maybe you wanted to join it up with some new data sets, you could actually do other aggregations based on this in specific columns, and you can even filter and alter them. So this is kind of that no code kind of interface that they also cater to at the same time of here, you don't want to write up all the code to actually do any transformations. That's great. You can use a data flow, and that can be then sent as a sync into whatever data you like, and that then pops up in a data set. So I pulled in an Airbnb data set, and I sent it to be synced into a selected data set, which also is there. That's great. I'm not too focused on the data flows and stuff. What I'd like to be able to do is really hardcore machine learning today. So we talked about that AutoML example. So we've got our data set, which is going to be our New York taxi data set. How do we set this up? How do we start predicting how much I should be tipping to the cab drivers when I get to New York? First of all, you'll pull in your Azure Machine Learning, you'll import it and create a workspace. So what this workspace is an Azure Machine Learning workspace. And this is where that integration comes in. This is how you connect to the products that Azure Machine Learning has while you're in Synapse. And all you really need is just a subscription ID, a resource group, and a location for it. If you look at SKU Enterprise, Azure Machine Learning Studio has two levels of subscription. One is a basic, one's an enterprise. Enterprise sounds terrifying. It sounds it's going to be really, really expensive. Don't be scared by it. All it does is the fact that a basic only has notebooks. Enterprise will actually be able to get you designer and AutoML features as well. The pricing doesn't change. It's whatever you use, you charge only for that. So once you've created a workspace, that's all it really needs. It takes a couple of seconds. I can then import any extra libraries that I might think I need in the kind of pipeline as I go. I've imported those, and I can just see exactly what I've set up. So I've got my subscription ID, I've got a workspace name, I've got an experiment name set up just so that all of this is stored in one place. And that's kind of it. I'm ready to go. So just a few more kind of imports I pulled in here, and just to make the data look a bit pretty if I decide to show any data. So we're finally at reading in our data. So we talked about the New York taxi data set. So I pulled in about a month's worth of data from the data set itself. So I just went straight into the open data sets that Azure has. And they've got the whole New York taxi data set in there. And from that, I just pulled a month of data, which is about 8 million rows, if I'm not wrong, and pulled that in as a pandas data frame. Pandas works really, really well from what I've been testing out in this. It's quite fast, keeps everything pretty straightforward, and is very easy to find solutions to in Google if you need to, like I did. In a machine learning kind of pipeline, once you've pulled your data in, the next step is usually kind of prepping the data. If you don't need any columns, drop them. Your machine learning model doesn't really need any extra noise that you don't want to provide it. So I've dropped a couple of columns here. And the next step is usually, I could always go back and do a bit more prep, but I left it at that. It's just like dropped a few because I want to see how AutoML can do. And split it into my training and testing data set. It's like being back in school. Your machine learning model, you teach it based on about 80% of the data, like go learn, this is how it works, figure things out from it, and then you test it at the end of the day to see how well it has actually learned overall. So split it into 80% of a training set and 20% testing. And those are my X train and Y train. This is important if you're not familiar with machine learning back in pipelines and stuff. So X train essentially is just kind of all the variables. And what I'm asking the model to do is based on all the inputs I give it in the X data set, which has every column except the tip amount. I want it to be able to predict my tip amount, which is the Y. So once I've segregated all that out, this is kind of what my data set looks like. So it's got the tip amount, but I've taken that out at the end of the day. And all you're really left with doing is setting up your AutoML run. So if we just take a step back before we kick off the AutoML run, what have we actually had to do in this? All we had to do is make sure our data was here, it was in the right format for what we needed. And that's kind of it. We don't have to worry about the actual machine learning part of it, of picking a model, picking the parameters that it needs. None of that needs to be done because you can just send it to AutoML, which we'll go through now, and that can do that for you. So what I want to do is predict a specific tip amount, right? I want to know exactly how, if fare is $20, how much of a tip should I be leaving in New York, what it should be like. And that's great. There's 3 different types of tasks when you think about machine learning. One is regression, which is predicting specific amounts, like the tip amount we just said. So I'm going to be using the task regression. The other task is classification, which is kind of the basic, putting it into bins, right? Is this a cat or is this a dog? That's classification. And the third one is time series. So AutoML can cater to all 3 of those. Time series is just if you've data based on any kind of timing and data baseline on it. So I want to use regression. So I tell it, okay, my task is regression, and you tell it what primary metric you want to use. So what this will do is it'll go through all of the models it has under regression, which I think it has about 15 models at the moment, and it'll find the mean, the normalized RMS error, and it'll actually
Is it only me?
do worst. Sorry.
Hi, are you back?
Was I out? Oh my God.
There is a bit of a technical issue over there. We can see and hear you now again.
Okay, cool. Anyone have an idea where I dropped off?
No, not really, but I think you can just continue.
Okay, no, that's okay. Cool.
All right.
So no, that's fine. So yeah, AutoML config is just setting up your kind of telling the AutoML exactly what you want it to do. So you tell it what kind of a task. So I've picked regression to predict specific price of the tip amount, like exactly how much I should be tipping, and a metric for how do I test exactly which one is the best machine learning model. So under regression, AutoML has about 10 to 15 different models, and what it'll do is go through each of them, and it'll figure out which one has the best RMS square error. That's great, and it'll just label them out and tell you which one comes back as the best one. So this just kind of takes out, even if you are a seasoned data scientist and you know exactly how to code up your models, what this can do is actually, instead of having to test 10 models, you can use AutoML. It'll give you back the top best 2 models, and you can just continue from there and really fine tune those 2 models instead of having to spend all that extra time looking through all the different types of them. So it can still work for everyone. It is still catering to that whole market. And the other kind of additions that you might want to add are just, how do you want to validate? I want to have 2 cross validations in this. I want to have 10 iterations through different models. And I give it my data. So my X is the inputs, and my Y is going to be, oops, let's just bring that back down. If you want to, thank you. And my Y is going to be the tip amount of predict the tip. And to submit that, I just say experiment.submit with the configurations that I've set out up at the top. And this is the longest it takes on any cell here. So every cell up until so far, it takes about 5 to 10 seconds. The importing the data, because it's about 8 million rows, I think overall that took about 2 minutes to convert that into a pandas data frame from start to end. And this takes about 45 minutes to be able to run through different models. And you can see why, because every single model, as it just gives you the top 10 here, you can see every model has a duration of how long each of them took. they kind of range from about 2 minutes to about 9 minutes-ish. And it also tells you the metric, and it keeps a track of which one is the best. So it ran the first one, and it was like, okay, cool, this is the best metric I've seen so far, and runs through other models, and it'll keep a track of the best one. And at the end of it, you can ask for it to print out which your best run model was, and you can see that model then in AutoML in the actual machine learning studio. And once that loads. So what you've gone to a stage of is you've pulled in your data, you've transformed your data, you've trained your data, and now you're kind of ready to deploy it. How do I actually deploy it? Well, you can do that through Azure Machine Learning Studio directly, where it's ready to go. You just hit deploy best model, and you can connect it up to a Kubernetes service, and that's off. It's ready to go. While you're in Synapse itself, you can also actually deploy them through ONNX models. You can leave those as return that as true. I haven't done much with ONNX, so I didn't go further than that. I left it at that, but I know Ron went through a whole heap of descriptions about ONNX earlier on. So if you want to have a go look through his talk, might give you a better idea. I know I will be looking at it afterwards to see what I can do with this. But this is kind of what AutoML integration looks like in Synapse, where you don't necessarily have to sit down and do a lot of coding to figure out what exactly machine learning looks like. It's ready to go for you. But on the other hand, what if you did want to do that? If you are someone who wants to be able to code up a specific model and really fine tune that to get the best performance possible, well, we can do that. As a data scientist, you'll go in, and this is where it's a little bit more nuanced in terms of really specific things you need and quite a lot more like workload intensive. So I've pulled in a lot of libraries, as you can see. And as well as that, I've pulled in my data. This time, instead of a month, I've actually only picked a week, just so that things would have been a lot faster. So I was going to run these all live for you, but as you can see, I've already dropped out once. The internet isn't being as nice to me as I'd hoped it would be. So I'm going to leave the live demoing and stuff out of this. I've got it all loaded, so you can have a quick look. So 1 week of data is about 2 million rows from this data set. And I've pulled that in as a pandas data frame, as well as a Spark one. So a caveat here, Spark has lazy evaluation. So it'll run everything. That's great. Like you'll see it be really, really quick at calculating all these things, but it's not. It only actually calculates and evaluates all of the filtering or transformations you do when you ask it to show anything back, when it actually needs to do it. It'll just check the code before then, like, yeah, that looks good. That's great. So it can end up taking a bit longer, but Spark is much better in the longer run when you have a really big data set. Because I only had a small enough data set, I just pulled it in as a pandas data frame as well, just to be able to see them really quickly. I'll connect that up to my storage accounts. And the kind of cool thing that I found was I've got these notebooks here open, and I want to see what's in my data stores and what exactly is my data. Clicking away to data doesn't actually remove anything on your screen. It just changes the little column on the left. And you can see your storage accounts here, and I've connected up my global AI storage as a primary data warehouse. And I can store it locally and cache all my data there, just so it's a little bit more faster because it doesn't have to keep reading that data from memory every single time I do any calculations. That's great. I've pulled in my data, and I'm a data scientist. I'd like to do a bit of exploration so I know what I need to do in terms of data prepping and cleaning out the data a bit more. So I'll have a quick look at let's have a look at this histogram. As you can see, kind of expectedly, most tip amounts are between $0 and $5, a little bit more on the end. A few people are being really generous and saying maybe $25. Maybe they took a really, really long trip. I don't know. We can have a quick look at maybe the box plot. And you can see there's quite a few outliers. I'll know like, oh, I might cut off the tip amount at maybe $25 just so that there's no really random or outlier kind of extra values and noise added into the model. And just a really quick look at what the correlation looks like from the tip amounts to the fair amounts. I can see there's going to be something there, and I'll let the model tell me exactly how well or how good of a correlation there exists. So for prepping the data itself, because I said, oh, I don't want all the kind of tip amounts more than 25, I'd like to be a bit more careful about it. We can do that as just writing out SQL statements. If the SQL is what you're comfortable with, you can literally write SQL statements in the notebooks and deploy them to the Spark, kind of get those to be calculated on top of the Spark. You can also do it in different formats. You can kind of go do it in PySpark, use Spark specifically, just code out all the solutions. or if SQL is very comfortable with, that's completely fine. It is kind of that flexibility that it provides you with kind of language agnostic performance here. So just having a quick look at what I've decided to do with the prep, I said, look, select just a few columns that I think I'll need, don't really need all the extra ones. I saw pickup date time, which was all these numbers. I'm like, well, I don't really want a value for every single minute of the day. I just want maybe all of them bucketed into hours of the day. So I pulled out the hour, and I also pulled out what weekday it was, because I think that's important, right? Mondays and Tuesdays might have a different tip amount and kind of how long trips are taking than the weekend might. So I pulled those out, and just the total overall how long a trip was in seconds. And I also kind of filtered through this data set here where, like we said, so I don't really want, because I'm going to be traveling maybe on my own, maybe my family, but definitely not more than like 4 or 5 people. So I left the passenger count like less than 8. Tip amount, like we saw in the histogram in the box plot, maybe I don't want to see anything more than 25, because then it just kind of becomes outliers in there and might confuse the model a bit too much. And just a few other kind of things like that, that trip distance should be less than 100 kilometers. So I don't really see myself taking a taxi for longer than 100 kilometers in Manhattan of all places. And that's kind of all it really takes. So you hit it, you get it to run, and you can create views from this to be stored and cached regularly so that it doesn't have to keep rereading through memory. So another thing when I've done that is I want to do a bit more prep and featureization. I've picked out all the hours, but I still think it's a little bit too much data in there. So I might segregate those into bins. We've got night, morning rush, in the afternoon, and the PM rush. I've pulled out all the hours into just 4 buckets and just distributed those through there. And I've also cut down kind of a little bracket of how long my trips actually take. There might be some kind of faulty data where a trip might be less than 30 seconds, and that just doesn't sound right. So I've removed any of those where it doesn't seem like a realistic journey in a taxi. Once I've done that, my data set now obviously has things like a column called a column called pickup hour, which has things called night, AM rush, afternoon. Those are words. A machine learning model and a computer doesn't understand words. It doesn't care. They're just strings to it. It's just things attached to it. It cares about numbers. That's how it understands things. So what we need to do is actually convert those into a way into integers so that the model can actually understand it. And this is going to be done through, I'll just segregate these out a bit so you can see it better. So what I'll do is for, say, the traffic time bins, I've got 4 bins in there: morning, afternoon, evening rush, and nighttime. And for the 4 of them, what I'll do is put a string indexer. What this does, it just gives it 1, 2, and 3, 4. Just labels everything and removes strings in your data. But that's great. In one column, it now has 1, 2, 3, 4 attached in it. And what the model might do is model might think that 1 is better than 4, or the 4 is better than 1. I don't want it to be doing that. That's including bias in my model. So one-hot encoding essentially removes that bias by just segregating those out into 4 columns individually and just saying, if this was a morning run, it'll be a yes, like a binary 1, 0. It'll be a 1 in the morning trip time. I did the exact same thing with the weekday string, just for it to be able to be vastly distributed as, was it a Monday, was it a Tuesday? It'll just be a binary one-hot encoded. And that's as much of a data prep as I did on this. So I've essentially removed any strings, and I've removed kind of any outlier values that might exist in the data. So now that I've done that, I'd like to be able to do again. I want to get it ready for my modeling. So I split into training and testing. And like we did earlier, last time we did 80%, this time I gave it 70% to learn from. I'm going to test the data on 30%. I'm going to test the model on 30% of that data just to see how well it actually did. And from there, it's right time to train the model. I won't lie, this was, I just pulled it in. I haven't had time to actually create my own model around this. But the person who did create this, it takes hours to figure out what works best, what's the best way to actually go and pick what kind of model it'll work, how many iterations, what are the parameters. 0.3 takes time to get to that number and see which one works the best. And running the model itself will take time too. So this is where in AutoML, I didn't have to do any of this, where the AutoML actually ran all of these codes and the modeling for me. Here, I've had to go through and figure out what someone else has to go through and figure out exactly what the best way to predict this would be. And once you've done that, that's great. Like, you can write out all your predictions and stuff into any of your data sets that you have. It works really well. It'll store everything for you, whether that be in the Spark pool or a SQL pool. It's more than happy to deal with any of them, and it can actually read and write to everything at the same time. I'm going to, so while I've been creating this demo over the last weekend, there's been a bug in the preview at the moment where it's having an issue with the linked service of storage accounts. So I couldn't actually write this out to the storage account for you to be able to see it today. But in the next time I hopefully show this where everything's a lot better, I'll be able to show that part of it too. And this is where it comes back down to what the integration part of Synapse all really is. It's the fact that you can have Azure Machine Learning Studio artifacts being pulled into one place. You can create anything. You can have all your data stores from multiple different places, whatever kind of data they have, all in one place, being able to read and write those, learn from those, train those from into the model, and actually output that in all in one conjoint area without having to really flick through too much kind of busy noise on the screen. So now that I've done that, that's great. So I've went through AutoML and I've gone through the notebooks. So this was just a clean, straightforward notebook of no other features being pulled in, just me doing coding. The other thing I mentioned was the BI capabilities. So what does the Power BI capabilities look like? So what you have to do is you'll attach a workspace, and that is just a one-click workspace where you can click through here, or you can create a linked service. So I've created a linked service here as Van Arsdale, and I've got a workspace already existing. And what this does is it pulls that workspace in, and it shows you everything in that workspace, including the data sets in that workspace. And from here, I can actually create a brand new Power BI report. And this looks exactly like what your desktop version of Power BI will look like. Maybe not up to its latest kind of installment at the moment, but it's still as functional as the Power BI desktop is. They are adding a bit more integration still to this, like connecting directly to a data source from Synapse itself. I don't think that exists yet. I haven't been able to do that anyway. You need to connect it to a workspace and then be able to continue on from there. But if I did want to just even quickly do a line chart of this just sort of data set with kind of values of the company. So if I look at the date and I'd look at, maybe don't care about geography, but the manufacturer that produced this, which one's the manufacturer? So the manufacturer that produced a product and what was the revenue for every manufacturer. It's exactly the same as Power BI Desktop is, with all the functionality that Power BI Desktop provides you. And you can go make a new completely full dashboard from this. I've created one here. I can just quickly show you if you'd like. This is the kind of, this is the dashboard in a day example that Power BI has. Just went through it really quickly, created a dashboard here just for you to be able to see. And this is all done in Synapse itself. So that functionality and capability exists, not perfect yet, but it is there. And with that, that's kind of all my demoing part of today finished and wrapped up. So I'll just flick back to the slides really quickly. As a recap, I know it seems a little bit all over the place because in my head, it seems a lot all over the place. If it makes sense, I'm really happy it does. If it doesn't, I'm happy to take questions at the end of this. But the whole point of today was to be able to show what actually the aim behind Synapse was and how they've managed to actually create it and what it now looks like. So they have been able to import 85 plus data sets, and they can connect all those up within Synapse itself. You can use Machine Learning Studio capabilities in there. You can use any kind of libraries that exist online at the moment, all powered behind compute power that Azure can provide through virtual machines and Spark pools. And once you've done that, you can actually then deploy those models to be inferenced and through Kubernetes services, as well as just maybe in machine learning and ONNX models. And once you've deployed those, all the insights coming in from those can actually be presented and visualized on Power BI at the end of it. So yeah, that is kind of the end-to-end, pulling your data in all the way out to building your dashboards. And I think that's actually me finished. I've possibly talked quite fast throughout this whole thing because it's only taken me 40 minutes. So if you have any questions, I am more than happy to take them now.
Thank you a lot, Akanksha. It was awesome and very interesting. It was cool to see so much code in the session.
I feel, yeah, there was a lot, and I was trying to keep it as bare minimum, as clean as possible. But yeah, I completely understand if there was kind of misinterpreted bits and something that didn't come through.
Yeah. So we have some questions actually. So first of all, is there any chance of you knowing about whether there will be, when will it be available generally, the Synapse?
It's a great question because I had to beg so many people to get access to this. Much begging that I did for this. So no idea. I don't think they've released any kind of even public preview announcement dates yet at all. It's coming. That's all I can say. It looks really cool. They're still building it out. I think there are some bugs and stuff that still exist, but like I actually am really enjoying even just the markdown things in the cells and stuff. You can preview that as you're writing it, like all these little functionalities that they have that I haven't seen before. Like it's looking pretty fun, and I'm excited for when it comes.
Yeah, it indeed looks pretty cool actually, and it's very interesting, and I also can't wait to get started with it.
I mean, if
So
other people start begging for it, I'm like, this is great. It just speeds up the pipeline for this, so it's good.
yeah, so is there a cost on the Synapse? Like, how costly is it? Or what recommendations would you suggest us to handle low costs?
So if I look at the data hat, so look, at the end of the day, this is built on top of data warehousing. That is still the functionality that it's meant to have, and that's meant for really, really big data sets, which at the end of the day, they are really, really efficient at handling those and not really that expensive comparatively for a price point. But for what I did today was a very small sample. So over the week, like I've had data stored in there for about a week now, which is about 200 gigs of data in there in a SQL server. I've had all the data processing I was doing was on about 10 million rows on average. All of that over the last week has cost me about $1. So I don't know if they are planning, if this is just kind of preview pricing yet. I haven't seen much around what the pricing will be indefinite once it comes out. But at the moment, it's very cheap. Is what I can say.
Sounds cool. Okay, so the next question. Any idea when will the Azure Machine Learning Designer be integrated with Synapse?
I'm assuming that's going to be a pretty secondary thing. I can ask and I can let you know on Twitter if you'd like afterwards. But if you've used Designer before, it's kind of interesting because it's a drag and drop UI. So essentially, it's just all these modules. It's kind of like a data flow, but for pipelines and machine learning. It doesn't necessarily really fit in with Synapse at the moment, where it's kind of a lot more code focused still. Azure Machine Learning Studio is great for what it is. If you just wanted to create a quick pipeline, it's there. You don't necessarily need it in Synapse at the moment. So I don't think it's a priority for them at the moment. But I mean, the way it's going, because they've already pulled data flows in, I'm assuming one day Data Factory is just going to be lapped up into Synapse, and it's just going to be one big product that encompasses them all. So same might happen with Machine Learning Studio.
Yeah, that's cool. There's a question that I'm also was about to ask something about this. This Databricks stuff.
Yeah.
And there is this question: why would you continue to use Databricks after the release of Synapse? I mean, there are some different functionalities for both of them. So so Synapse has this Power BI integration as well, and Databricks is very capable of maybe computation. But what is your opinion about these two right now?
At the moment, I haven't used Databricks as much as I could have. Like, I won't lie, I don't have much experience in Databricks at all to be able to actually compare the two, really, to have an opinion based on this. Like, for my uses and my use cases here today, and like for the last little while that I've been working on, like Notebooks does everything just fine for me. It doesn't take hours for me to do anything, so kind of happy where I am.
Yeah. Okay. All right. So another question. So can't you build a Power BI dashboard directly based on data that exists in Synapse at the moment?
I wasn't able to find that. You still need to create a workspace at the moment, which already has dashboards and stuff included in it. I wasn't, but also it could just be the fact that there was the bug this weekend about not being able to connect the data stores properly. There was just issues with linked services at the moment. So it could just be that I just didn't see it and I couldn't do it this weekend. But from what I could see anyway, it hasn't come through fully yet. You can still create reports, just not straight directly from the Synapse data yet.
There's one more question that I am trying to translate now. So I think it means that, so when do you think Microsoft will release Synapse Analytics?
Yeah, no idea. They will not give me any ideas about that at all.
No.
I don't think they're tying themselves down to a date yet. But I mean, in the couple of months, I'd say we should see at least a public preview or new features pulled through.
Nice, thank you a lot. Do you have any questions, Willem?
So, yeah, I haven't seen Synapse before, actually. I heard about it a few weeks ago. And one of the things that strikes me is that that Microsoft is trying to put just about everything that's related to data analytics in one box.
Yeah.
Yeah. So it's kind of funny to see. And at this point, it's a private preview, I guess. So, so how far along are they in actually integrating all the products into one thing?
I would still see it as like I don't know if it's going to be something like PowerBI, which has like a monthly release of a new update altogether, or it's going to be a lot more slow building because they're doing it at such a larger scale of really, really big products that stand on their own. Like SQL Data Warehouse has existed for a long time and people are very happy with where they are and know exactly what they want to do, but it's now changing a little bit. So I don't know how quickly they'll import everything into one place. It might be really slow, or they might just be like, no, this is it, one place for all, here's the solution, off you go. It depends on what they're kind of pitching this as.
I could also imagine that companies that are currently running on-premise data warehouses are actually, I know that they are looking at using cloud computing to move their data warehouse away from the on-premise expensive, error-prone service into the cloud. This might be actually something that they want to look at because it's a one-stop shop, actually.
Exactly.
Is that also what you're seeing at your customers or the companies that you work for?
We've seen, I think, maybe one or two. We've done POCs, I think, somewhere and stuff. There's a few POCs popping up in terms of Synapse about really using the product for what the preview is, which is essentially just a data warehouse at the moment. But that promise exists of, okay, great, build up your data warehousing now and move it all here so that once you're ready to go, the functionality will actually pop up. It'll be in general availability for you to be able to like put all your solutions in one place. So the move has started, I think, from what I can see in terms of, right, this is the time you can get everything ready for when all the new functionalities do appear.
Cool. And what would you recommend for companies that are just starting out? So people that are not doing AI just yet, but are getting started with just gathering data from their company. Would you recommend them actually jumping onto the bandwagon of Synapse or just start out with a smaller solution? I can imagine that this is pretty big for them.
It depends on the size of the data they have. At the end of the day, I think data warehousing, just in the naming of warehousing, it's like, oh, just a place to store your data. It's not really. Like if you've got, I think, 500 gigabytes of data, like that can be a very efficient SQL database, like in SQL Server. Like it's fine there. You don't need a data warehouse for that. So yeah, if there's companies starting to like look at the size of your data, if it is big and it is something that needs to be stored in a warehouse, like in its actual form and function uses, great, go for it. This could be something really cool for you. Just be really aware of it might not actually be cost efficient for you if you've only got a small amount of data in there and you're still running all of the performance levels that it needs.
Yeah, I can imagine that if people start to use this and they start jumping into Databricks like functionality using Spark, this can be very expensive actually, despite the fact that they might not have the gigabytes of data that Spark is suited for.
Yeah. And it's kind of always a struggle of like, oh, this is really, really cool. I want this, but there's definitely easier ways and cheaper ways to still do the same solution. even if it might not look as snazzy and brand new as other things might. But yeah, it's hard to fall into the pit trap. Buzzwords are everywhere, right? It's always going to be a thing. It's kind of why AI is as loud in the market as it is, but it's coming through.
So, and in that regard, you demonstrated using automated machine learning. Is this something that you can run locally as well?
All of the machine learning stuff I did, the AutoML stuff was run local. Like that was all local run. And there's two versions of it. You can run locally, you can run remotely. I just picked local run just because it was quicker, I think, for me. Essentially only because my data was smaller. Like it was only like, what, 2 or 3 million rows? Like that's fine.
Yeah.
I was happy enough running that locally. But yeah, both of those exist.
Cool.
Well, thank you a lot, Akanksha.
No problem.
I just wanted to mention that right now soon a poll will be available at our chat, which is available at chat.globalai.community. And I want to say thank you very much again for this session, Akanksha, because it was really interesting and really awesome.
I'm glad.
And if
I can't
there is
see anyone's faces, so I'm like, okay, understood. This is great.
But yeah, so if there are any questions coming up on the way, or we didn't get to answer a question, you will maybe get an answer later on.
Yeah, I'm happy to answer on there. Even after today, like my Twitter is available, is open to everyone. Reach out, more than happy to answer questions. Love talking to people on Twitter. Like, come follow me. This is great. I love
Thank you a lot.
Thank you so much.
Hey, my name's Akanksha Malik, and I'm from Melbourne.
Excellent Somi, it's Val here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
I'm Prasant from California.
大家好，我是卢建辉。
I'm Alpha Cassie from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joe Spizak from California.
Hi, Midi Eddie Daoud, Greece, Africana.
Hi, I'm Anna from Anna.
Merhaba, ben Türkiye'den Daron Yönden.
Hi there.
Hi.